Dear students, welcome to virtual classroom of Municipal Corporation of Greater Mumbai. I am Sreekumar. The class is for 10th standard students. Subject is mathematics. Let me begin the class.
Dear students, we are continuing with the same chapter, circles, entering into a new concept related to circle, and it is touching circles. You studied about congruent circles which are having same radius, concentric circles which are having common center, intersecting circles which will be intersecting or crossing at 2 points on the circle. Further, you learned that there can be circles passing through 1, 2 or 3 points, and we found that innumerable number of circles can pass through a 1 point or through 2 distinct points, but only a unique circle can pass through 3 non-collinear points, and no circle can pass through 3 collinear points. These are things you learned. Later you came to know about tangents of a circle, a tangent theorem you studied. You also found that the tangent drawn from a point outside the circle are congruent. We named it as tangent segment theorem. You applied that, and you must have done certain sums given in your textbook in the problem set practice 3.1 that you should do before going ahead with this video. Here it is touching circles. As the name indicates, it is quite simple, but there are certain aspects you will understand from touching circles. So let me go ahead. How to draw touching circles? In order to draw touching circles, you cannot draw a touching circle. Certain measurement or certain idea is required to draw that. For that, I am taking this scale over here, and I will be marking 3 points with the help of this scale. It is my idea of drawing two touching circles, and I am marking it here at a distance of 3 centimeter, at a distance of 5 centimeter. 3 points are put, and I will be taking a compass now. Compass is very necessary in this chapter. Compass is the most friendly thing in this chapter because we are talking about circles in this chapter. This is our compass, and I am going to draw circles with respect to these points. In order to see the circle clearly, differentiate the point, let me change the color. Let the color be somewhat like this, which can be easily. Okay, here is one circle which is drawn, and another circle I am drawing by keeping the compass here and taking the distance between the second and third point as radius, like this. Okay, so now let me draw the second circle. Now I succeeded in drawing 2 circles which are touching at a point. Understood? The purpose of putting the point was to get it properly. So now I can write over here this point as x, and this point as y, and this point, y cannot be seen, y, and this as z. Okay, and even I can, these 2 circles are touching at a single point. That point is named as y here. I am thinking about drawing another set of touching circles. For that I will be marking 3 points again, but slightly differently I will be doing this time, marking at 3 and 4. Because of space restriction, I am changing the measurement 3 and 4, and I am going to draw circle. How to draw circle in this case? Bring the compass and I will be drawing a circle with my second point as its radius. This is one circle which I am going to draw. Okay, and another circle I am going to draw keeping this point and the same point here as its radius. I am drawing a circle. Here also we can see that these two are two different circles touching at a point. If I mark the first as X and second as Y and third one is Z. Here the peculiarity is that one circle is inside the other circle. Moreover, we are having a certain other peculiarity. This is the point of contact can be marked perfectly at a point. And if I try to measure this distance of this, which I had put earlier for my convenience, here it is 3 centimeter, This is 3 centimeter, and again here it is up to 5 means again 2 centimeter, and the total is equal to 5 centimeter. The total, I can show it like this. Understood? The distance between the center of two circles, I would say. Otherwise, this is again, here it is 3 centimeter, and here this one is 1 centimeter plus, that is 4 centimeter. That way it is. First one is having a radius, I would say 3 centimeters. Second one is having a radius 4 centimeter. Now if you think about the distance between the center of these two touching circles. Two touching circles are there, and I am trying to find out there is a point of contact also. Now when measuring this circle or measuring the distance between the center of these circles, we can see a peculiarity. In the case of this kind of touching circles, if it is touching externally, this is called circles touching externally, bahar touch hota hai. We can see the line joining the center, if you draw, or if you try to find out the distance between the centers of two circles, it will be the sum of the radius, or radii of both circles, which is equal to 5 centimeter. If they are touching internally, and if you try to find out the distance between two circles, it will be the difference you will be getting as the distance. Here it is 4 minus 3, which is equal to 1 centimeter. This peculiarity we notice. Very simple thing, but a peculiarity of touching circles. Throughout the chapter, you will be learning number of peculiarities of circle, which you will be applying later. So you can pause the video here and practice at 3.2. You can attempt, where you will be getting chance to draw circle, touching circles, externally touching circle, internally touching circle. Sometimes you have to find out the measurement and all. Enjoy it. Then come back and continue the video further for another aspect of circle which I will be explaining. But I cannot stop here. I will be continuing. You can pause and practice from the textbook and then come back. Okay, so let me erase whatever I have written here, remove the compass and remove the scale, etc. You will be practicing now. This is what I said. When it is externally, you will find the sum as their distance, and if it is the circles are touching internally, the difference of their radii will be the distance between the centers. Now the next concept you have to learn is about arc of a circle. What is an arc of a circle is, when we think things, it is very simple. I would say that arc of a circle can be drawn very easily. Whenever you hear the term arc of a circle, what should come in your mind is a broken piece of circle. Correct? If I ask to draw an arc of a circle, I will draw like this. This is an arc of a circle. This is also arc of a circle, quite big. So बैंगल का टुकड़ा जैसा है arc of circle, correct? This is also arc of a circle. But by definition, when we think of how and when arc of circle is formed and what is arc of a circle, then there is a definition. For making you understand the definition, let me draw a circle here. Here is a circle. And if you draw a secant into that circle, what is it? Secant. Here is a secant. The secant will intersect the circle at 2 points. Right? Here is a point at which the secant is intersecting. Here is another point where secant is intersecting. By that the circle is divided into 2 parts. And there is a set of points here which is making a part. This is a set of points which is making the bigger part of a circle. Each part is an arc. And these all together make the arc. All the points in this part of the circle and all the points in this part. And we know that the center of the circle is somewhat here, on one side of the secant. Which side of that secant, the center of circle, that side makes the major arc. There is no center of circle in the other part which is minor. This is something interesting and should know. Major arc is there, minor arc is there. Major arc is on that side of the secant where center is there. The other side is minor arc. This is about concept of arc. You should be very clear. Definition you will be learning as such because definitions are scientific. Any one of these, a secant divides a circle in 2 parts. Any one of these 2 parts and the common points of circle and the secant constitute an arc of the circle. Let us go ahead. Another concept, I told you, full of properties. Central angle. What is central angle? Central angle बोलने में एक सेंटर है तो सर्कल का सेंटर ही है. और एंगल बोलने में आपको क्या याद है? एंगल का वर्टेक्स रहता है, एंगल का आर्म्स रहता है. Now circle and angle together at one place. Then we can explain central angle. For that again I need a circle. Compass is the main instrument here. I am going to draw a circle here with this center. Okay, this is my circle. A circle is drawn. Now you need an angle. The angle can be drawn. I am drawing an angle this way. Here is an angle which I am drawing with the vertex at the center of the circle. Vertex of the angle is the center of the circle. Then we call it as central angle. तो मैंने central angle बना दिया. ठीक है? क्यों central angle बना दिया? We are going to study about arc and we know what is arc. Now we are thinking about how to measure arc. तो उसमें ये क्या काम आएगा? 2 things are there mentioning here. One is the measure of this arc. Measure of the arc is the measure of the angle. And plus this length of this arc is decided by the radius of this circle. 2 things will decide the size and measure of an arc. So center angle drawing is done in order to make you understand what is the concept of measure of an arc. Measure of an arc. Is a rectangle. Measure of a minor arc is equal to the measure of its corresponding central angle. So this is a minor arc now here. We know that this is a minor arc now. And this is a major arc. What is the measure of the angle of this central angle? That is the measure of the arc. तो हम सच्ची में कितना है देखने जा रहा हूँ. चलो. We'll take the protractor. Keep it here, and it is 60 degree. The measure is equal to 60 degree. So the measure of this minor arc is 60 degree, and the remaining will be major arc, which will be 300 degree, because total degree around the circle is 360. Understood? But on the other hand, if it is a semicircular arc, what is a semicircular arc? Semicircular arc is that arc which is having the shape of a semicircle. Semicircle is formed when the angle is the diameter itself. Okay, Seva? Suppose that this is the circle. And if we are making a diameter to it, or we are trying to make a central angle in such a way that passing through the diameter, how it can be? To make an angle, I need one particular, this one, and the second one, if I make from the same point here, it becomes an angle like this. And here the measurement of the angle will be 180 degree, because it passed through the center. Understood? So this arc is a semicircular arc. Semicircular means half circle. Understood? So this concept also should be clear to you. चलो आगे बढ़ता हूँ. Congruence of arcs. Congruence of angle is in its measure. Congruence of segment is in its size, that in centimeter or meter. Congruence of circle is in the congruence of its radius. Then what is the congruence of arcs? In order to understand congruence of arcs, you need to compare arcs. In order to compare arcs, you need to have more than one arc. So I am going to draw a circle having more than one arcs. For that I am taking the compass and drawing circle here with a point given. Here is a circle. I will draw a little bigger circle. Here is a circle with the center over there. Now we need arcs in that. In order to get arcs, measured arcs, we should draw arcs having particular angle measurement. We will measure the angle later, but we will be making an arc like this. We got an arc. We need one more arc of same measure. तो क्या करना पड़ेगा? पर इसको measure देखना पड़ेगा. To know the measure, what we should do? We should have the measuring protractor with us. So we'll measure it. Simply measure it, whatever is coming right down. 50 degree. ये मुझे नहीं समझ में मेरा accurate ऐसा number सब कैसे आ रहा है. This is 50 degree. That is a measure of the arc. one more arc to be made of same, so that we can say that these two arcs are similar or congruent. One side I made, so in order to draw the second side, second arm, better I use protractor and find a 50 degree from this side. I am drawing here from this side. A 50 degree can be marked here. Remove the protractor, connect it. You are making the second angle, central angle, and the measure of this is known to me now. It is 50 degree. So what is happening here? Here it is 50 degree, and these two arcs are congruent. Why? Because their measure is congruent and the span is same because of same radius. तो फिर क्या है? Two things required, measure and radius. तो radius required कैसे prove करेंगे? It is better take the compass again here, keep it here, same center. Either expand it or make it shorter. I am making it shorter. Drawing another circle with same radius, same center, not radius. Another circle. In that circle also there are arcs formed here, arc formed here. Expansion is same because measurement 50 degrees is same. This expansion of the arms. But this particular part, the size of the arc is not same because the radius is different. This is R1. This radius is R1. Different radius. First one was R, bigger one. So radius change होगे तो measure of arc change हो जाए. So there are two things to be considered. Both measure of the arc is considered by measure of its central angle and the radius. If both are equal, the two arcs are considered to be congruent. Okay, very important, interesting. Let us go ahead. I know that it is quite a long video, but you can pause at any time because I cannot pause because this is related topics going on. Topics are such that all are interconnected. Sorry. What is next in your textbook? Next in your textbook is two theorems which are important but easy to understand. Theorems are proved in your textbook. I will not be taking each and every step of theorem, but I will give you the clue how it is proved. The theorem is that chords corresponding to congruent arcs of a circle are congruent. क्या इधर congruent है? Congruent arcs है. The chords corresponding to that congruent arcs will be congruent. For that we should have again congruent arcs. जो भी बनाया था मिटा दिया, चलो वापस बना दो, फास्ट बना दो, congruent, sorry, फास्ट बनाने वाले तो गलत हो जाएगा. Congruent arcs बनाने जा रहा हूँ मैं. कंपास लाया, पॉइंट डाला, देखिए बेटो, और सर्कल बना दिया. ठीक है. अब इसके अंदर कॉन्ग्रुएंट आर्क्स बनाना है तो कॉन्ग्रुएंट एंगल बनाना पड़ेगा. एक आर्क बनाया, सेम मेजर का वन मोर आर्क चाहिए. So we'll have another side of it we will take. और दूसरा मेजरमेंट करके लेना पड़ेगा. So I need the protractor. How much is this? I will check. This is 54 degree. The same measurement I need here. for the other arc also. So I will mark 10, 20, 30, 40, 54 degree. ठीक, marking तो हो गया. Now you need to draw. Okay, two arcs are formed. I can name it as arc. Oh, sorry. ये हमेशा होता है. Arc A, B and C, D. They are appearing to be congruent because the measure over here is 54 degree and 54 degree. Now it is saying that if you draw chords corresponding, chords किधर आएगा, chords इधर आएगा. Connecting these 2 points, you can have a chord. Here is connecting these 2 points, you can have a chord. This is 6.7 centimeter. पहले वाला देखना भूल गया. Yes, it is also almost 6.5. This one is, repeat कर रहा हूँ, 6.56 के उधर है. So these two chords are congruent. That is what is the theorem. एक ऐसा theorem तो हमेशा सही रहता है, लेकिन हमको थोड़ा proof चाहिए ना. प्रूफ कर सकते हैं, प्रूफ आपके टेक्स्ट बुक में है, लेकिन अभी प्रूफ कैसे किया उसका टेक्निक बोलते हैं. ये दोनों ट्रायंगल कॉन्ग्रुएंट प्रूव किया. लेट अस मार्क सी हियर. ट्रायंगल ABC and triangle C, sorry, C इधर आ गया तो E करता है इसको, E करता है, E. ओके, ट्रायंगल ECD, ये दोनों कॉन्ग्रुएंट प्रूव करना पड़ेगा. कैसे प्रूव करेंगे? This is radius, this is radius, this is radius, this is radius, this is 54 degree, this is 54 degree. तो अपना जो कॉन्ग्रुएंसी प्रूव करने का जो टेस्ट है ना, 7th स्टैंडर्ड SAS, यस सेम है, AS सेम है. तो SAS टेस्ट से दोनों कॉन्ग्रुएंट प्रूव करेगा. दोनों कॉन्ग्रुएंट प्रूव करेगा तो ये दोनों कॉन्ग्रुएंट प्रूव करेगा. दे आर द करस्पॉन्डिंग कोड्स. Understood? So that is the mechanism of proving the theorem. Theorem is given in the textbook with proof. उधर तो step wise आपको लिखने को सीखना है. 9th standard से लिखने को सिखा रहे हैं. अभी सीखा होगा तो फिर प्रॉब्लम नहीं है. नहीं सीखा तो this is the last chance to learn that should be learned, no doubt. Let us go ahead. What more there in the textbook? It is given almost same another way. What is given? Corresponding arcs of, उल्टा हो गया, congruent chords of a circle are congruent. अगर chords congruent हैं तो arcs congruent रहेगा. तो इसमें हमारे पास क्या नहीं रहेगा? इसमें हमारे पास, जरा मिटाने का कोशिश करता हूँ. We are trying to use the same figure. थोड़ा एडजस्टमेंट करता हूँ टाइम सेव करने का. ये जो 54 डिग्री है ना, वो दिया नहीं है. ओह सॉरी, अपने हाथ से गया. डिजिटल वाले ने हमारा प्लान फेल कर दिया. I will remove this. I will remove this and I will explain the theorem to you. The theorem says that corresponding arcs of a congruent chords of a circle are congruent. So arcs congruent if chords are congruent. This is the situation of the theorem. For that again, you will be drawing the equal chords here. For that again I need compass and I will be drawing an arc circle here. This is my compass and I keep the compass here and I am drawing the circle, and you need to have congruent chords inside this. To draw congruent chords, I need a line segment here. Let it be a chord of 6 centimeter. One chord is drawn. Another chord I will draw here. It should be of 6 centimeter again. Okay? Now the thing is that if you draw chords and make arc accordingly, first arc is measured by central angle, so I should make central angle from these chords, and that end point of the chords are the end points of the arc also. Now in this situation, the argument or the theorem is that this angle will be congruent to this angle. Measure करके तो हमको मिलेगा. Geometrically prove करने के लिए I am going to name this triangle simply, quickly and simply. Let me name the triangle as AB and the center C, and this as D and this as E. Think about our theorems of congruence of triangle. If I consider triangle ABC and a triangle ECD, ABC and ECD, ECD की जगह पे वही ऑर्डर पे लिखता हूँ, ABC, EDC. If I think consider these two triangles for comparison of congruency, testing congruency, we know that these are radius. पहले की जैसा. So two sides already congruent and chord is drawn congruent, construction say. So by SSS test, I can prove these two triangles are congruent. Once the triangles are proved congruent, I can easily say that these two angles are congruent. So using the congruency test of triangle, we will prove that corresponding arcs of congruent chords of a circle are congruent. अगर एक circle के अंदर congruent chords है, उससे बनने वाला arcs भी congruent होगा. बहुत बड़ा discovery नहीं है, but you should know how to prove it with the help of congruency of triangle. So I am not going further. Let us recap what we learned in this chapter. In this video. Chapter तो खत्म नहीं हुआ है. We understood that an angle whose vertex is in the center of a circle is called central angle. One aspect you studied about that. Then we studied about what is meant by minor arc and major arc. Understood? That you learned. You also learned that two arcs are said to be congruent if their radius and the measure of the two arcs are equal. They should have same radius and same measure, that means central angle. We can add the arcs measure if they are in the same circle with same radius. We can add the measure of the arc, and we also found that if the arcs are congruent, the corresponding chords are congruent. If chords are congruent, the corresponding arcs are congruent. Understood? This way, our conclusion. Lot of properties of a circle you will be learning in this chapter. Certain theorems also. It is very important in further chapters also. And it is interesting because it is related to circle, angle, and thereby to the earth, and in a larger way to the understanding of geometry, which is very important. Thank you.
Now click on the subscription button below to subscribe the channel, then the bell button to get the notifications of the new videos. Thank you.